All right, welcome back. We're now on to 3.2, and in section 1, we kind of learned to graph and find out where they intersect, and that's a great method too. But we're going to lose some more algebraic methods. Two methods today. We're going to talk about the substitution method and the elimination method, sometimes referred to as the addition method as well. And again, as we kind of look back at this, what we're finding where the two lines cross, the intersection point. That's the solution to the system of linear equations. All right, now again, what we did in section 1 is that we put them into y equals, we graphed them, found those points. Well, we can do the similar type of thing here with substitution method. Now, just like you can take 4 quarters and that's a substitute for $1, well, same thing here. If we know that y equals x minus 1, what we can do is we can then substitute that in for y. Okay, so here's what we'd have. We'd have x plus, now in place of y, we're going to put x minus 1. That equals 7. So all we've done is we've substituted something in for the second equation y, something that's equivalent to it. Well, what that does is it gets us down to one variable. So what we can do here is we can add these two together. We can get 2x minus 1 equals 7, and then 2x would equal 8, and then x, of course, would equal 4. So 4 is the x-coordinate of the point of which they cross. Now what you can do is you can take that 4 now and you can put it back into either one of the two equations to solve, and it doesn't matter which one, to solve for y. So if we put 4 back up top here, well, 4 minus 1 is 3. There we go. And the nice part is you can always check to see if your answer is right. Put a 4 in for x and a 3 in for y. Is 3 equal to 4 minus 1? Yeah. Is 4 plus 3 equals 7? Yes, that's the only point that will work for both of those. So it's a nice thing because then you know for sure if you are correct, just like we did in section 1 where we gave you the point. Well, now we're figuring out what the point is by using that substitution method. Okay, so again, nice algebraic way of solving it. Let's try another one of those, and as we get going here, and there we are. Okay, all right, so once again, now it doesn't always have to be solved for y. You could solve it for x and go that route about it. It doesn't matter. But since this one's already solved for y, we're going to take this 2x minus 1 and we're going to substitute in for y. And a little tougher this time. We have 3x plus 2. Now in place of y, we're going to put 2x minus 1. Good idea to put that in parentheses, by the way. And that equals 26. Okay, so 3x, now we have to distribute. Okay, so we get 4x minus 2 equals 26. We'd have 7x is equal to 28. So once again, x equals 4. Okay, doesn't always equal that, but there we go. All right, now once we have that, we can put it back into either one of the two equations. Well, it looks like the top one's pretty much solved for it, so let's put a 4 in. 2 times 4 is 8, minus 1 is 7. And let's just double check the bottom one. 12 plus 14 is 26, so we know that we are correct. All right, so that's the substitution method. Now, it's not always going to be the case where it's going to be solved for one letter, one variable or the other, but you can always solve it for whichever variable you want to, if that's the case. All right, well, let's talk about the next method algebraically, and this one's called the elimination method. And what we're going to do, it's sometimes referred to as the addition method, what we're going to do is we're going to try to add the two equations together, and in the hopes of eliminating either the x or the y. And you can kind of see right now, if I add these together, well, I get a 7x. You notice the y's are eliminated. Haha, very good. Yeah, that's what we want. And then, of course, here we get a negative 14. Solving for x, x is negative 2. All right, now again, your choice. You can put that x back into either one of the two equations. The top one looks a little easier to me, so let's see. We'll get negative 6 plus 2y is equal to 4. All right, so 2y would be equal to 10, and y would be equal to 5. 5 is what we have there. So again, it looks like we're solved. It looks like they check out for both of those, and there we go. Now, I know what you're saying. It's not always going to work out where if you just simply add those, the x or the y is going to cancel out. We're pretty fortunate in this case that it did. It doesn't always work out that way. So let's look at a case where, well, what do we do then, right? What happens if it doesn't just eliminate naturally? Okay, something like this. Now I get 5x and 8y. Well, nothing eliminated. All right, now you have the ability to change either one of the equations, one or both, and in the hopes of getting it to eliminate. Now, these two, and it could be the x or y's. In this case, let's eliminate the x's this time. I think if I could get this one to be a 6x, and let's put the bottom one, make that a negative 6x. All right, what would happen there is we should be able to, sorry about that, we got a little glitch in there, okay. We could be able to get those to eliminate. Well, in order to do that, I'm going to have to multiply the top equation by 2. Now, when you do that, you have to multiply everything by 2. So this becomes a 10y, and this becomes a negative 32. Most often, people make a mistake. They forget to multiply everything by that number. Now, on the bottom, we're going to multiply it by negative 3, giving us the negative 6x, so that cancels. This becomes a negative 9y, and this would become a positive 27, is what we would see there. Now, when we add these together, the x's are eliminated. Oh, look at that. This works out really well. We get y is equal to, well, it looks like negative 5 is what we'd have there. So my point of intersection, that's the y value. And again, take your pick. This time, let's use the bottom one. Doesn't matter. We'd have 2x. Let's see, if I put a negative 5, that'd be minus 15 equals negative 9. So 2x would be equal to 6, and x would be 3. And again, if we did that, I think we'd work out that everything should work out all hunky-dory. Yeah. So there we go. All right, now, another thing that can happen is kind of this idea when we have two lines that are intersecting. You know, we found out, yeah, they could intersect at a point, but something crazy kooky can happen, as we kind of mentioned before. You know, we could have it where you have no intersection, they're parallel. They could be the same line, or they intersect at one spot. Well, what happens here, let me show you a couple examples. When you're maybe doing this, let's say that we're doing the substitution method. Let's say that we solve this one for y by moving that negative 3x to the other side. Notice what happens when you substitute in over here. What happens is we get something that's crazy kooky. We get 2 is equal to negative 18. Now, we know that that's not true. That's a contradiction. So what we know then is that there is no solution. Okay, there's no solution going on because that's not true. It can't happen. So these lines actually turn out to be parallel. All right, now again, when you're solving, let's say once again you're using the substitution method, you find out here that, oh, okay, well, let's see. Well, yeah, we've got this going on. I think we solved this one for y here by moving that negative 7x, put it into the top equation. Now this time the variables cancel out, but this time we get something that's true. Negative 32 equals negative 32. That's true. So if that happens and we just get a true statement, then that's what we call the identity, in which case they're the same line, in which case we'd say there are infinitely many solutions. Okay, so keep that in mind as you're solving those. So again, today, substitution and the elimination method. We'll get some good practice with that. Great ways. And the nice part is when you get your answer, you remember, you can always check it to see that it's right. All right? So that's it for 3-2. Until next time, I'm Mr. Boone.